My other presentation from the Kotlin Conf, where I'm going in the beginning of October. So these are completely new, never before seen Kotlin puzzlers, like a premiere for you. So Kotlin, for those who don't know, or is there anybody who doesn't know anything about Kotlin? Even, okay, a little bit fewer than those who have used it, but still there are. So it is a relatively new JVM language. It's designed to be compatible very well, interoperable with Java. So basically you can write half of your code in Java, half in Kotlin. This is how it was designed, because JetBrains, who is the developer of Kotlin, they made this language first for themselves, so they can develop their own products like IntelliJ IDEA and all kind of IDEs and other products that they have. So now also there is a compiler that compiles Kotlin to JavaScript, a subset of Kotlin. Then there is also Kotlin native, which targets iOS and other native platforms. So it's not only a JVM language anymore. So it was pragmatic and concise. So it's you need to write less. It's modern language than in Java, for example, and it's open source, and it has obviously very good tooling from the start, because it's developed by the company who produces and sells IDEs. So basically, when designing the language, they skipped all the pitfalls of Scala or dynamic languages to create the language that is so that they be able to provide good tooling for the language. And it's since previous year, it's now the official language of Android. So that's maybe a short introduction. So it took 6 years to get to 1.0. So it's actually, they started it in 2010, the year when we started Codeborn, actually. And they changed the logo during these years. And given the amount of time, it should be a perfect language, of course. And it took SpaceX a little bit less time to be able to land the rockets back on Earth. So SpaceX use Kotlin? I don't know, but there are many companies who do.
They would manage to do it faster.
Maybe. So, and now to puzzlers. So puzzlers is a like, who has been to a puzzlers talk before? Not everyone. Okay. So puzzlers basically is a type of a conference talk where I present you and or somebody else short programs in some given programming language, and you need to try to understand what this program does. Basically, I show all the programs in the IDE, but as a warning for you, I have errors and warnings disabled, so you will not get the help from IDE to understand the thing. And so, all programs, they print something. So you need to guess, we will be voting for what the programs do print. So, and then I run the program. So it's not like the only slideware, we do it the real stuff. And then we see what really happens. And if needed, we need to also discuss what's the thing. So yeah, Kotlin was also designed to avoid well-known Java puzzlers. So it doesn't have many of the Java puzzlers, but of course it has quite a few of its own. So it's a pragmatic language, not ideal. It was designed to be a great tool for developing stuff. It's not a scientific or not a, like, theoretical language. And all the puzzlers are tested and run with fresh Kotlin 1.3 release candidate, which is available already. So, ready? The puzzlers are available on GitHub as well, so you can submit new ones. And so we start with the first one. So the first puzzler is called Many Hellos, and is basically, if you're not familiar with Kotlin, you probably can still recognize that we have a function called hello with return type of Boolean, and it calls another function, which is println, which calls another function and another function, and then we call this function. So there are the options that that program can print. So what do you think? So obviously, I can help you that obviously this should be executed first, I think, from the outer function. It's like a normal language. So so it's like there should be probably hello, should be world, or if the program compiles, of course. So what I, of course, need to warn you that if there are options in puzzlers like will not compile and something else, then you should very carefully consider these options, because otherwise they wouldn't be puzzlers. So who thinks that the output of this program would be just a hello world? Like some people? Great. So who thinks that it will be hello world false? I think there are more people thinking that there will be false. Okay. Who thinks that will be hello world true? Not so many. So, and who thinks that this is a nonsense, it shouldn't compile? The D means that you think that it should not compile. It's a not normal program. Yeah, so let's now run it, and let me see. Drum roll, and it's hello world. So who has guessed A? You can try to explain. Anyone wants to explain, or yeah?
So it executed from left to right. So it first did printing, and then it returned false and didn't print out false because it wasn't told to print out false.
Yeah, that's correct. This return actually it returns earlier than this print is actually run. So yeah, that's correct. But why is it at all possible to do these kind of things? Why does it compile?
I come from dynamic programming language.
So there you can write just any stuff. Yeah, the important thing about Kotlin is that it's a completely statically typed, type-safe language. So yeah, and anyone can guess why you can?
So what's the type of the return statement?
The type of the return statement is nothing. So basically in Kotlin everything is an expression, and most of the statements like return and throw, they're also statement expressions, and their return type officially is nothing, but nothing can have no instances. So if we look how nothing is defined, then it actually has a private constructor, so there can be no instances of nothing. And compiler uses nothing actually to mark the code that that is unreachable. Basically, in JVM, nothing is mapped to Java lang void, for your information. But yeah, that's why everything has a return type. That's why you can actually compare. And what do you think is the return type of print?
True like
Nothing.
No, it's not Boolean. It's actually it's a mapped function in the JVM. It's the same as standard system out print that we all use on the JVM. So which in Java returns what? Void, yeah. And in Kotlin, the void is mapped to unit. Unit is another type, which is a really useful thing, is that it's a type that can have only one instance. So because it's an object, oh sorry, so there can be only one unit, and that's why actually if we return this, if we remove this thing and run it, then we actually get the option C. So we should. What?
We need to return Boolean.
Yeah, we need to return something, so let's just return false here. So, and yeah, then we get hello world true, because both prints return units, and units are always equal. So that's the thing, and that's it's actually it's a really good thing, because you can use print also in expressions and avoid Java void methods, which is really useful. So let's proceed. The next puzzler is submitted by a Japanese guy. So you can see we have some integers and we cast them. So here probably, to those who are not familiar with Kotlin, I need to explain a little bit that the question mark means that this type is nullable. It means in Kotlin, by default, types are not nullable. So you cannot assign a null to a variable. So they are fixing the $1 billion mistake that is exists in Java. So and the triple equal sign, so it's actually the reference equality, the same as in Java the 2 equal sign, because the 2 equal signs in Kotlin is the equality by value. So it's like the same as calling equals method in Java. So, and we have here like just comparing a little more stuff. So probably you have already been able to parse the program. So let's vote on the outcome. So who thinks it will be true, true? Which is like an obvious answer. I would think that it should be true, true, true. Yeah, not many people. So you don't think that puzzlers can have an obvious answer? Good. So who thinks it will be false, false? B. So there are a little bit more people. Who thinks it will be true and false? C. There are even more people. So.
Which doesn't make sense.
And I think the D would be the rest of the audience. So who thinks the D, none of the above? It's even less than C, probably. So yeah, let's just run it and see. So the drum roll. And it's true, false. So who can explain?
So it's initialization in Java when it's from minus 127 to 127, they create this pool. String literals, let's go with it, remember by heart. So then in this case, when they compare from minus 127 to 127, it will be kind of like primitive comparison.
And that's correct. The thing here is that the JVM also uses the boxing like Java, and in Java all the numbers from minus 128 to 127, they are cached, like their values. So they are boxed by just reusing the instances. That's why this one is the same instance, and this one after boxing is another instance. Can you tell me why there is boxing at all happening here? It's because we are casting it to the nullable type. And nullable type, of course, requires boxing, so it's not the primitive type anymore. So yeah, that's the thing. So to get the true, true, we just make it like this. So I have actually never seen any program in Kotlin that uses the triple equality. It's not really useful. So the next one is inspired by Eric Yigi when I showed the last set of puzzlers in Codeborn. So another puzzler with integers. So before you start guessing, I can tell you this is the minimum int, the minimum value of the 32-bit signed integer. So what happens when we increment it? So not much code here. So what do you think? Like with option A, meaning that its absolute value will decrease. Then, yeah, go. Okay, nice. Then option B, like it will get past the boundaries of min-int. So, yeah, why not? Then option C, that it will overflow, like integers should do when you increment the smallest number. And who thinks there will be none of the above? Something else. Okay, then let's run it. Drum roll. And it doesn't compile. So it's D is the correct answer, none of the above. And who can guess why?
Oh, it says 1.
Yeah, obviously, but can you explain why is so?
Order of execution.
Yeah, that's correct. So the thing is that the functions, extension functions in the Kotlin compiler, they have the precedence over the unary operator. So basically this minus is a unary operator, which is a unary minus, and it's executed after the incrementation happens. And because incrementation produces a bigger number than int can hold, then, or actually this number already is a long in Kotlin because it doesn't fit into an int. As you know, that's always the smallest negative number, its absolute value is 1 bigger than the biggest positive value. So that's why it's long, so we increment it, and yeah. And obviously, if we use here the just regular print, then it works, because here we pass it to a function that requires an int. That's why it doesn't compile. So, but if we do it like this, then it's just a long, and everything works. So you get the option B. So let's proceed. Breaking lines. So as you can see, Kotlin is a nice, concise language that doesn't use semicolons. So semicolons are not modern anymore. They feel like old crap coming from C++. So why should you write them? And of course, in Kotlin, you can write semicolons if you really want to, but the official code style enforces you not to. So, and imagine you have some variables. Val in Kotlin means that it's an immutable variable, basically a value, like in Scala. So we have 2 and a 2. Then we have some list that we map to the sum of these values. So list has only one element. So basically this map function should be executed only once. And yeah, so who thinks that the result of the mapping will be a list with 1? Nobody. Okay. Who thinks the result will be a list with 2? Just one hand. Okay. Who thinks it will be 4? Yeah, I would think it will be 4. It's obvious. And who thinks that it will be 1 and 4? For some reason, and the rest of the people think that it will be none of the above, I guess. So yeah, let's see who is right. Maybe the rest of the people are right. Okay. And the correct answer is B. So who can explain?
Plus is a unary one.
Plus is unary one, correct. Why?
Because it starts on the beginning of the line.
Yeah. So this is the price you pay for the language without semicolons. Basically, in Java, these kind of things cannot happen because you need to always finish the statement with a semicolon. If you do the same with JavaScript, probably, or any other language which doesn't need you to put the semicolon, you need to be careful when you're breaking lines, because you can.
This will work correctly in JavaScript.
Yeah, I know. This concrete example, but there are others that will not. So yeah, so a compiler in a semicolon-less language need to always put its own decision where the statement ends. And in this case, Kotlin compiler thinks that these two look like completely separate statements. And the result of lambda is actually the value of the last variable. So that's why it's 2.
Suggest any legitimate use of a unary plus operator where you would need that kind of thing? Or would someone put that into a language?
Unary plus is used with Kotlin DSLs, but I don't have any other like mathematical use for it. And but the thing is that you can always you can also use the unary minus, or like if you use the. Actually, I haven't tried it that way. So this is the way how to fix it. So you need to terminate the line with the, so that for compiler it's obvious that it's not over yet. But if you write it like this, then maybe it will work. Let's see. Yeah, this one doesn't work for the same reason. So, so a compiler thinks that they are two separate statements. So let's proceed. So now let's look a little bit at more of the simple code. So we have two variables. One is nullable 2. One is non-nullable, which is 3. Actually, in Kotlin, in the second case, you don't even need to declare the type because the compiler can easily infer it. In the first case, it will infer it as int, so you need to declare it as a nullable int. So, and we just sum it, and this operator, who knows what it does? Yeah, it's called Elvis operator, so it's basically checks if x is a null. If it's null, then it uses the value on the right. So if it's not null, then the real value of x is used. So it's just like Groovy. This operator comes from Groovy. So who thinks that the result would be 3? Oh, there are some people, okay. Who thinks it will be 5? Like kind of obvious answer. Who thinks it will be only 2? Somebody will eat the 3. Okay, and who thinks it will be 0? Okay, at least one person. So let's run it. Drum roll, and it's 2. So, anyone?
Order of 0 plus 3 is the
3.
0 plus 3 is the average value.
And
so the thing is that it's executed like this. So yes. So this operator has a lower precedence than the plus. So if you want to have 5, obviously, then you may write it like this. So if you use it in an expression like that. But yeah, it's actually the same thing that exists with Java ternary operator. Also, the precedence there is not always obvious. So the next puzzler. It's about the collections now. We declare a list of 3 integers. Then we check if it's a mutable list. And if it's a mutable list, then we add 4 to it, and then we print it. So if you don't know what the type of list of returns, we can check that it's actually, okay, it's too small here, but it's just a list. It's not a mutable list. So you can see it returns a list. And in Kotlin, there is a difference between list and mutable list. So the plain list is not mutable. So they have fixed Java in this respect. So what do you think? So basically the question is, will this comparison succeed or not? Or will it compile at all? So who thinks it will be 1, 2, 3? So the immutable list will stay immutable. Yeah, I kind of also joined this party. So who thinks that is B? It will be somehow an element will be added. Yeah, there are some people. Who thinks that it should generate an unsupported operation exception, meaning that the if should succeed? Yeah, there are some people. You will need to explain it if it's true. And who thinks that it will not compile because compiler kind of sees that it's not mutable? Yeah, there are some people, and actually Kotlin's compiler is quite smart in some of the cases. So let's see. And it's unsupported operation exception. So who can explain?
Maybe is. It is not a type check. What is is?
Is exactly the same as the instance of in Java. So it is a type check. So we check here if it's a mutable list, but Who can explain why this is succeeded, but by add did not?
And you don't have to put any semicolon for after if?
No semicolon tricks here.
So just spaces.
Oh, that's not true. Okay, I think I should explain that myself. So the thing is that Kotlin learned from Scala that Scala has tried to fix Java collections as well, and they have created completely new collections. The problem with Scala approach was that when you needed to interrupt with Java, you needed always to convert your collections from back and forth, and it's really bad for performance. So you needed to wrap and unwrap and copy elements. So Kotlin, they still wanted to have better collections than Java, but they wanted them to be performant as well. So they actually decided that the list and mutable list are both mapped to the Java util list, but only compiler, like at compile time, compiler ensures that if you have a list which is not mutable in Kotlin code, you will never be able to mutate it. So basically it doesn't have the list interface in Kotlin, it doesn't have any add methods. But the thing is that when we do the check at runtime, then we can actually bypass the safety of the compiler and we can still do bad things. Exactly the same way as you can do with Java generics. So you can have a list of integers, but at runtime you can put the string into it and it will break. So if you don't do this kind of runtime things, then you are safe. And the thing is that the implementation of list here is actually, it still doesn't allow adding of elements. So at runtime it also preserves the immutability of the list, just in the same way as collections unmodifiable list in Java does. But it still is an instance of Java util list. That's why at runtime Kotlin cannot do more than is possible in the JVM.
Can you jump into mutable list? Where does it go?
It is a Kotlin mutable list, the same as the, so it's mutable collection in the stands Kotlin list, and Kotlin list has fewer methods than the Java util list. So, but at runtime compiler on the JVM, it maps it to the Java util list in JavaScript, and Kotlin native, of course, this code would produce a different result. So, a little bit more about the collections. So, we have again a list. In this case, it's an array list of some elements. We sort it because array list is actually a mutable list. And so we can sort it and we can print. So who thinks that, not a lot of code, probably you have already seen it. So who thinks that the order of the list will stay the same for some reason? Nobody? Really? Yeah, one brave person, nice. So who thinks that it will be sorted, like option B? Like obviously it should be. Why would we call this sort method? Who thinks that this code will not compile? Maybe I lied to you, an array list of is not a mutable list. Yeah, there is somebody. And anything else? None of the above?
Will it return some, print some boolean, like true sort?
Yeah. Okay, very good for you. So many people already start understanding how it all works. Yes, the Kotlin unit is the return type of sort method, because this sort method is directly borrowed from Java, and in Java it mutates the list. I actually gave you a hint before that array list of is a mutable list. That's why it has the sort method, and the immutable list doesn't have it. Immutable list has another method which is sorted, and that one would give the option B. So it will be actually sorted. A copy of this list will be returned. So another puzzler. So it's called abstract null, and a little bit more code already. So it's starting to getting more advanced. So I'm really proud that you guessed. Many people guessed the previous one. So we have abstract class called null safe lang. It has a property, abstract property called name, and it has a property called logo, which takes the first letter of the name. And there's a class Kotlin, which extends class null safe lang and overrides the property name and specifies its own value Kotlin with lowercase k. So, and then we create a new instance of Kotlin. You can see we don't write new in Kotlin. It's a little bit easier. So compiler can always understand when it's a function, when it's a constructor. And we can read what is inside of logo. So what do you think? Will we get the k?
What does val mean?
Val? Val means it's a value. Yeah, it's a property.
Immutable property.
Yeah. Val is a immutable property. Yeah, you cannot change the value of it. So it's the, like if you write var, then it's just a mutable property that you can change later, but val you cannot change later. You can only assign it once. And here you can think of these properties about the same as Java fields. So in this context, I think that it's not much difference.
Well, you cannot have a final abstract field in Java, so this is what you're writing here.
Okay, so yeah, so in Java, this would be compiled to get name. Yeah, that would be an abstract getter in JVM. And so the vals, they have only getters, and var, they have getter and setter. So they're compiled to both. So that's why you can override it, and you can specify a new value. So who thinks we get the k, the logo of Kotlin? I would think so. No? Everyone put their hands down, then I said that I would think so. So who thinks that we get the null pointer exception? There are some people. I didn't mention it that Kotlin almost gives you the null safety. So they say that if you write code that doesn't produce any warnings or errors, you should never get null pointer exception. Basically, it's the same promise as there is in Java with generics. You will not get class cast exception if you don't write code without warnings. So, and who thinks it will be illegal state exception? C. Some also people. And who thinks that it will not compile? Kirill thinks that changed his mind. Yeah, there is. It exists. Kotlin null pointer exception. Yeah, we'll get to it later. So, drum roll, and we get just a regular null pointer exception that we should not get normally. So who can guess?
Oh, it looks like a regular Java exercise when the class is not constructed yet.
Yeah.
And you already get the property.
That's completely correct. So because here actually this one is not the body of the getter, it's the initializer of this field. And if you want this to work, then you write get here. Then this expression is the body of the getter. Then it will be executed later when you call it. But if you don't write it, then it is accessed actually before this class can put its own value there. It's because the parent class is initialized
like
first.
Only a method, not a variable.
Yeah, but still, this is like, this declaration is exactly the same as you would write string logo in Java equals. So it's just the initializer of the
But it should be
field.
get name.
Yeah, it calls get name, and at this point,
If the get name is implemented, then
yeah.
it should work in Java.
Yeah, it should work if we implement get name. So we can implement get name like this. But because we haven't implemented it, we just provided the initializer. So basically what happens is that this thing is executed before this thing, because the parent class is constructed before the child class. So yeah, if you don't overwrite values like this, then you're safe. So when you're overriding values, you better provide a new getter, not the initializer. So then another interesting puzzler with a few lines of code. So we have a mutable list again. The type of elements of the list is lambda. Lambda that takes no parameters and returns nothing. Basically just a regular runnable in Java. And we get the empty mutable list, then we go from 1 to 3 and we print values of I and j. We actually add them to the list and then we go through them and execute them. So again, to clarify, the type of the elements which are inside of the list, they are lambdas, executable by blocks of code. And so we fill the list with lambdas and then we execute them all. It's like the messaging that Derek was talking before. So we have a queue, we fill it with some stuff and then we process them. So, anyone ready to vote? So let's start with A. So who thinks it will be like everything in correct order? 1s, 2s, and 3s. So yeah, we believe in the initial assumption. So who thinks it's B? So it will be, for some reason, 3 will stuck. So there's like couple of hands. Who thinks it's C, like the 3 in I was stuck? There are more people. And who thinks it will be something else, totally different? D. That's always a good answer to vote for. So if I would be giving money for the answers, then that would be the best answer for sure. So let's try. So, and the correct answer is C. So I heard Eric told C before, so why?
Lambda is executing after the increment. The I is already free when we execute lambda.
Yes, that's correct. So actually, if we would remove lambda from here and execute them right away, then we would obviously get A. So it will work as expected. And here, actually, the thing is that E is a var. It's a variable that can be changed. And here we actually use the variable that has changed already. So when we execute it here, then we already get the last value of I in all of the cases. But J is actually its value. It's an immutable, and that's why it's passed to the lambda as an immutable value. And it's a part of the, like the ETA which says that it's captured in closure. And this one is passed by reference, and that's why we get this result. So this kind of thing is not possible in Java at all. So you know, in Java, in order to use something inside of a lambda, it needs to be final or effectively final. But in Kotlin, you can use variables in lambdas, but you get what you get, basically. Actually, I tried the same thing in JavaScript, and in JavaScript, the correct answer was 333333, because obviously in JavaScript there is no immutable variables. And in Java, it's not possible. So another one. So we have a function that takes 2 booleans, and it just prints it, both of them. And we have like some numbers here, and we compare them. So like quite easy code, I would guess. So even for the late evening. So what do you think? Would it produce true and true? Who thinks it will be true and true? You need to look up the numbers. So who thinks it will be false and false? Some people hesitant. Like C, come on, C is like 3 and A is like 1. So yeah, it should be false. And they are all immutable also, so there are no tricks with mutability. And who thinks it will be null and null? C? No one? Yeah, where does it come from? So D. Anyone? A couple of hands. So let's now run it. And it did not compile. So why?
I think because print statement is executed in the declaration, and A and B doesn't exist at that point, no?
No, that's not true. It's actually much easier. I need to show you, enable the errors. And actually, I consider it's a bug, as a bug in the compiler. But I'm sure that at Kotlin Conf, the JetBrains will explain me why it's not. Basically, if you can see, compiler thinks that this is a type parameter. So if you write it like this, and it works. So 6 years in development and 2 years more, and maybe there is a reason for that. I will ask the creators. So what's the thing with it? But this puzzler was submitted to me twice, like in a little bit different way. So it's obviously something that people really run into. So another one. Not a lot of code. So we have a class called hipster, and you can see it. Here we have these type parameters. Now the real ones, and we have a type T, which is defined. Like an in and out in Kotlin is a better way to explain the same thing that bounded wildcards do in Java. So the bounded wildcards, familiar thing, I guess. Question mark extends, question mark super. So this syntax is taken from C#. So in C#, the bounded wildcards are called in and out. So basically, they are actually easier to understand. So if we take hipster, then hipster, according to type T, is a consumer. It takes T in. And if it would be out T, then the hipster would be a producer of T. So it would be output T. So it's easier to understand than super and extends. So, but what we have here is that we have in one place in and the other place out. And we create an instance, we eat burger and fries, and what do we get? So hipster, because he has an in, he's a consumer, so he consumes stuff. So who thinks that A, he will consume burger and fries successfully? A couple of people. So people don't believe in consuming of burger and fries, or don't believe in hipster consuming them. So who thinks that is B, class cast exception?
So how can a
Couple of hands. Yeah.
How can a function argument have something out producing? Okay, so adding things to that set.
Yeah, because it's like if you define the object that has some relation with T, this object can be either consumer or producer of T's, then you can cast this object to the super type or the subtype of T. Or it can be both. In this case, you don't write in and out. Then you cannot cast it to something that has a subtype or supertype of T. So basically, list of objects cannot be cast to list of strings, and vice versa. So yeah. So basically, and you can have an object that is both. And you can define methods which are in or output, and then compiler knows what can be passed to this method. So now let's get further. Who thinks that is C will not compile due to conflicting variants? You will need to explain what a variance is. Who thinks that D will not compile due to failed type inference? Yeah, some hands. So let's try. Obviously, it will not compile because there are even two options of not compiling. And yeah, it doesn't compile. So, and yes, the problem is with type inference. So basically, here the answer was much easier. Compiler doesn't know what is T when you just create the instance of hipster. So it can be fixed very easily, like this. Like we don't care what is T. So what do you think in this case it will happen? A. Okay, let's run it again. And yeah, that is A. So why we don't have the variance problem?
Because I don't know what it is.
So basically, variance, this in and out things, they are called in computer science, they are variant types, and there are like two subclasses of variant. They are covariant and contravariant. Covariant means that you are consuming T's, and contravariant means that you are producing T's. But here we have in and here we have out, and for some reason it works. If I enable...
Because you're not trying to custom it to anything.
Yeah, actually here there is a very interesting warning that the compiler shows that this projection is redundant. It's actually the same as just writing this, because hipster is already a consumer of T. And this is actually the same. So if I write like this, then it's a compiler error. So you cannot write like this because now you are having conflicting variants. And the thing is, it's hard to understand. I will leave it as a homework. So basically, when you're writing these variants in a type or in a method, they are reversed. And you need to think why. It's actually quite logical when you think about it. But it's probably as difficult in Kotlin as it is in Java, so these kind of things. So a couple of more puzzlers. So we have a data class. Data class in Kotlin is a really nice thing that actually generates all the boilerplate for you in Kotlin. So all the equals, hash code, compare to, and whatever. And you can define fields or properties of your data class or any class actually as constructor parameters. They will automatically become fields, so you don't need to specify them twice or even 3 times like you do it in Java. Then you create classes. So, and this example also shows a nice feature of Kotlin. It's a delegation. You can see that container actually extends list, or implements it in this case, because list is an interface. And there is a by keyword that means that this is the delegation. It means that it implements all the methods of list by delegating to items that is provided here as a constructor parameter. So then what we can also do in Kotlin, like in Python, we can destructure classes, even lists and whatever. So we can actually define 2 variables that will get 2 components of container. So you don't need to write container equals container, then you write container.name, container.items. You can destructure it if you need it. So obviously we need to get Kotlin here and a list here. So, and then we print it. So obviously it should be A. No? Yeah, only one person thinks so. So then what about B? There will be some disappeared items from the list for some reason. No? Nobody? Maybe C. 1 and 2, yep. So the Kotlin will disappear, yeah? And who thinks this will be D? Only 2 will stay? Also some people. So all the options got some votes. And it will be hello Kotlin 2. Like, I think I saw a hand there. It's actually really difficult to explain. It's one of the hardcore puzzlers that I have for the guys at the Kotlin Conf. So yeah, for you, I just wanted to show the features of the language, which are pretty cool. And the thing here is that the data classes, they really automatically generate methods, component 1 and component 2 for all of their fields, so that you can destructure it. So destructuring works for classes who have methods named component 1, component 2, component 3, and so on. As many as there are components, so you can have so many variables when you're destructuring it.
What's the point of creating a class and then immediately destructuring it?
Of course, there is no point, it's just a puzzler. So all of this code that I'm showing...
Why have this feature?
It's not immediately. Maybe in some cases you want to destructure it much later. So you want to like pass it somewhere. It's just like a more convenient way of getting stuff out. So instead of writing like, you can also destructure a collection. So you can like, if you care about the 2 first elements, you can write like this equals list. And you will get first 2 elements from this list. So you don't need to write get 1, 0, get 1, something like that. So there is some point, but yeah. And the thing here is that because we are delegating to a list, and list also has component 1 and component 2 methods. And actually there is basically a conflict. So the thing is here, which component methods wins, the containers or the delegates. So basically we get here that the component 1 is won by the container, component 2 is won by the list. Why? Let's see, like the author provided some explanation as well, so we can look at it. That's why, because it's private. Yeah, the thing is, yeah, the trick here is that this would work correctly if items is not private. And because items is private, then the component 2 of the container is private, and that's why, but this delegation shows you the component 2 of the list. So, and I think, because probably you're already, I'll show you like only 2 more. So, in Kotlin 1.3, there is a new cool feature called Unsigned Numbers. So finally, on the JVM, you can have unsigned types. That I think Gosling has written in some documentation of Java 1.0 that probably we will introduce the unsigned keyword soon to the JVM, but it never happened. Obviously, he thought that nobody needed it, but actually, if you're working with, if you're writing networking code like I do, you very often need unsigned types. It's quite inconvenient in Java to work with bits and bytes, and if you're working with IP addresses or something like that, you need to always think about the sign that should not be there. And the thing is that in now Kotlin 1.3, there are now unsigned types. And they're called uint or ulong and whatever. And there's also the u that you can use for literals. So you can assign unsigned 0 to x. And then obviously you can do something with it. So Kotlin allows you to implement operators also. Only the really small set of operators that you can like redefine for your class. So that in Kotlin, when you're working with big decimals, of course, you use the normal plus and minus. You don't write .add and .subtract. So, yeah, that's about the theory. And the practice, what do you think will happen when we take the unsigned 0 and we decrement it? So obviously, we will not get -1, right? And what happens, yeah, in both cases, there is a decrement. So these numbers are, this number is a maximum value of unsigned 32-bit integer, just for your information. So who thinks it will be A? So it will be decremented once, it will be overflown to the max value, then you will decrement it again, and you'll get one smaller number. Nobody thinks. For me, it's quite a almost obvious answer. Okay, who thinks it will be B? Like, yeah, these are the guys who have burned their hands in C probably, or C++. You guys know that this thing will decrement X, but still pass the old value, right? And this will pass the new value. So this is the thing that Kotlin. Yeah. So this is something that Kotlin probably also like inherits from C, like all the other languages which are newer. Okay. So B, no. I would think it should be B. Okay. Who thinks it's C? For some reason. So we lose the unsignability. Okay, and who thinks that it should not compile? So compiler will not allow us to decrement 0. Nobody. Or some people, yeah. But the rest of you? None of the above? And the correct answer is 0 minus 2. So I need to tell you that this is an experimental feature in Kotlin 1.3. So actually, to use this feature in Kotlin 1.3, you need to enable the experimental features of the compiler. Otherwise, unsigned numbers will not be available to you. This is because they are still testing it. So maybe there will be some refinements and whatever. So the thing is that when we actually uint is implemented as of course a class that has int inside of it, and it's, for example, mean values or max values defined like this one. So everything is obvious, and but there is also a new feature of Kotlin. It's called Inline Class. So Inline Class is created for performance. So this is something that I'm really looking forward to, because this will allow us to use the type-safe classes for things like usernames, passwords, or something that you usually use a string for. And usually you lose the type safety. You can just pass these things around and you can mix them up. So inline classes, they also a compiler-only feature that doesn't exist at runtime. So it's compiler checks that where you use this uint is always a correct place, but in runtime it's just a regular int that is inline. So these functions, they are implemented like also on regular ints. So, and here I need to now remind myself what was the real point of this stuff. So let's look here. Yeah, there is the boxing. So normally the inline classes, they are not boxed. So you just take so in reality there's a regular int is traveling in the code at runtime. So, and they're just, I think it's just a bug in the compiler that I found, that when you do this kind of thing, it will not get boxed. So if you do it like this, it will be boxed properly and it will be printed like it should be printed. So let's see. Okay, yeah. So these are warnings. So we get like the correct answer, like this one. But if we do this, then the compiler gets fooled, and it doesn't box the x anymore. It just passes it as int to println, and println prints the int. So not the boxed x, which should be converted to unsigned version of it. So yeah, this is because println is a universal function that has all of these versions of it. And if it would be a function taking uint, it would work properly. I think I'm out of time, so thank you for the test run of Java Puzzlers, and Kotlin really Kotlin really is a cool language. I think I've shown some very cool features to you of the language, and in reality you don't stumble upon these kind of things too often.
So thank you, Anton, so much. A small act of gratitude from our side.
Yeah, so I can use it here in the office.
Yes, exactly. And back to the JetBrains licenses. Here are sheets of paper. Here are also pens.